Okay, we have here today another integral on the board. We've got the integral from 0 to 2 pi of cosine to the 10th x dx. Okay, now my first problem here really is the large exponent, the 10. What we could do on this is we could do the power reduction for cosine squared and reduce it multiple times, but I think that would be pretty messy. So what I wanted to do instead here is I wanted to go back to a formula that I derived in a previous video on cosine to the n of x. Okay, now we have our formula here on the board, and this only works when n is even, but we've got 10 as our exponent, n. I can write my original integral as I of 10. And then our b and a is just the boundary, so our b value is going to be 2 pi here, and our a value is just going to be 0. So now what I can do is just go ahead and use this formula and start plugging in. So for our I of 10, first we're going to have n minus 1 double factorial, so that's going to be just 9 double factorial here. In the denominator, we're going to have our n value, we're 10, so we're going to have, this is going to be over 10 double factorial, and then our b minus a is just going to be the difference of the bounds. So this is going to be 2 pi minus 0. But then I can just expand out these double factorials and get some simplification. So the double factorial is very much like the regular factorial, except we're decreasing each term by 1. So we go 9 times 7 times 5 times 3 times 1, even though we don't really need the 1. And then for 10 double factorial, we can write this as 10 times 8 times 6 times 4 times 2. Then 2 pi minus 0 is just going to be 2 pi. But I can cancel 2's right here. See, I can cancel a 3 with a 6 and get another 2 there. I can cancel 5 with 10 and get a 2. And I think that's all the cancellations. Now we can just multiply this out. So we'll have 9 times 7 or 63 pi over 2 times 8 is 16, 32 times 4 gives me 128. And so that's it. Our solution is just going to be 63 pi over 128. So again, I'll provide a link to that other video where we derived this. Also in that video, we had a formula for the odd case, and then we also had some slightly different formulas when the integrals for sine instead of cosine. So we'll stop it there. Thanks everyone for watching. Have a great day.